Hi, my name is Brandon Graisley. I'm a high school math teacher, and we're going to factor some more complex trinomials. The earlier video I showed you how to decompose a complex trinomial, and that center term needs to decompose into two pieces, and then you do some common factoring to find all of the factors. We're going to do a few more examples. So let's start off with one which has all positive numbers in it. 6x squared plus 25x plus 14. And so remember, we're looking to decompose this center value here, the middle term. Its coefficient is 25, and I want to find two numbers that are going to add up to this number and multiply that to the same thing as these two out here. So I want two numbers that add to 25 and multiply to whatever 6 times 14 is, which is 84. So two numbers that add to 25 and multiply together to give me 84. Now that's kind of a largish number, 84, but what we should do is factor that number. Think of the different pairs of numbers that can multiply to give me 84. Now I happen to know that 7 times 12 is 84. That's one that I memorized as a young man. 7 times 12 is 84. That's great. Can these two numbers add up to 25? They don't. That's only 19. So let's try, well, I'm going to double this and cut this one in half. 14 times 6 is going to be the same thing, right? There it is up there, 14 times 6. 14 plus 6, though, is only 20. Okay, well, let's see. How about 21 times 4? That's 3 times this and a third of this. 21 times 4 is 84. That's good. 21 plus 4 is 25. That's great. That's what we're looking for right there. Two numbers that work. So that's 25 is the sum of these two numbers. So I'm going to split it apart. So pardon my equal sign going way down here. 6x squared we leave alone. This 25 we're going to split into two pieces. 21x and 4x. And then we have our plus 14 at the end, our constant term. So we just split apart the 25x into two pieces. We haven't changed anything else. We've just rewritten 25. And now we use our common factoring magic to look at the first pair of terms here and see what's in common. Well, there's always an x in common because there's an x squared and an x, and it looks like there's a 3 in common. This number's even and this number's odd, so there's no 2 in common. So just a 3 coming out of there. 6x squared divided by 3x is going to leave me with 2 times x. And this term, 21x divided by 3x, leaves me with 7. Now I'm going to end up with another one of these over here. Between these two terms I have a 2 in common. That leaves me with 2x plus 14 divided by 2 is 7. Good. These should come out to be the same thing. If not, you've got a problem somewhere. And now, common factoring out the 2x plus 7 from each of these giant terms leaves me with the first half, 3x, and the second half, 2. So we've successfully factored that expression. Alright, let's try another one. How about one with some negatives in it? 2x, oh sorry, I'm getting ahead of myself. 8x squared plus 6x minus 5. Okay, so we're looking for two numbers that are going to add to 6, and I'm going to write positive 6, and they're going to multiply to 8 times negative 5, which is negative 40. Okay, wow, so two numbers that multiply together to give me negative 40, but add together to give me 6. Well, negative 40 has to come from a negative number and a positive number being multiplied together. So we still need to find two things that multiply together to give me 40. So I could try like 1 times 40, and one of these would be negative and one of them would be positive. I guess the bigger one would be positive, so I want to end up with a positive difference between them. So the difference between those is 39. That's not very good. We'll try 2 times 20. Let's see, 20 minus 2 is 18. That doesn't work very well. How about, let's see, 4 times 10. 4 times 10 is 40. If I had positive 10 and negative 4, that would add up to positive 6. So those are the numbers that I want right there, 4 and 10. So let's rewrite our expression then. 8x squared negative minus 4x plus 10x minus 5. Now it's really, really important that you get your signs right on this. Minus 4 plus 10 is the same as plus 6. If you get things mixed up in here, these expressions won't be equal and you're not going to factor this properly. Okay, so now we're ready to do our common factoring of our first terms. Oops, sorry, let me switch to blue. Here I see a 4 and an 8. That's got a 4 as a greatest common factor. And x squared is x. This leaves me with 2x. And here we have minus 1, right? Negative 4x divided by 4x is negative 1. Okay, and now down on this side, I'm going to factor out, it looks like, a 5 from each of them. That's going to leave me with 2x minus 1. Hey, look, they're the same again. That's what I want. That's what I'm expecting. Now common factoring, 2x minus 1 times 4x plus 5. All right, we did it. We've successfully factored our expression into a nice binomial. Okay, let's do one more. And where is this one? I want to try this guy. Negative 2 times x squared plus 7x minus 3. Now you can see this one has a negative coefficient at the beginning. You can leave it like this and you can do it like this. It'll totally work out. Or you can factor out this negative 1 first to give yourself a positive trinomial, a trinomial that has a positive first coefficient. I don't know if one's really better than the other one, but I'm going to show you how to do this by leaving this alone. The danger of factoring this out and then working with what's left is you might forget about that minus sign that you factored out before. And so that's kind of a dangerous way to approach this. So let's do it just like this. We're going to look for two numbers that add to this number here, positive 7, and that multiply to negative 2 times negative 3 is positive 6. Wait a second now. Two numbers that add to 7 and multiply to be positive 6, those are both going to be positive numbers then. We're looking for positive numbers even though we've got all these minus signs in here. Okay? Because this is a positive number here, and we happen to be looking to break it apart into two positive numbers. It doesn't matter that there are minus signs all over the place. Okay, well let's try to figure that out then. 6 can be written as, well, I know it can be written as 2 times 3, but 2 plus 3 is only 5, not 7. 6 can also be written as 1 times 6. Hey, that works pretty good. 1 plus 6 is 7. So that's what we're looking for right there. Let's rewrite our expression. Negative 2 times x squared plus, now these are positive numbers, right? They add to a positive number, they multiply to a positive number. So that's plus 1x, or x, plus 6x minus 3. And you see we've rewritten our expression. It is the same thing. That middle term has been decomposed into two terms. Now we do our common factoring. From here, we see that there is an x in common. I'm going to write that first. Now we've got some decisions to make. We can take out a negative 1 if we want to from each of these terms and end up with just a 2x on the inside, or we can just take out the x. Either one's okay. I'm going to just take out the x and show you what happens. So this value here divided by x gives me negative 2x, and this divided by x gives me 1. X divided by x is 1. Okay. So this is a place that when you're more experienced, you'll be really careful about how we do this. Right now I'm going to see these two terms and notice, okay, I've got a 3 in common from each of them, and that's going to leave me with 2x minus 1. Okay, this is the time to be very cautious and careful. Let's pause and notice that these two binomials are not exactly the same. They're really close and really similar, but they're not exactly the same. And this is why I mentioned on this step, when you're choosing what to factor out, you might choose to factor out a minus sign somewhere along the way here. So this number, or this expression, negative 2x plus 1, and this one, 2x minus 1, they're negatives of each other. If I took a negative 1 out of this or multiplied it by negative 1, I would get the other one. So I'm going to do that right now from the front one, I think. I'm going to take out a negative x, and then here I'll have positive 2x minus 1. Okay, so I've made this negative, and I've taken the negative of this to get the opposite value. Alright, this one stays the same. I haven't changed the expression, I've just sort of moved the negative sign out of this part and put it out here. And now I have the same expression here and here, and I can successfully now factor, common factoring, 2x minus 1 multiplied by the first part, negative x, plus the second part, plus 3. And so we've successfully common factored it. Just to show you really fast, if I had done this differently at this step, I could have factored right here by taking a negative x out of this first part and been left with 2x minus 1, and then done my plus 3 times 2x minus 1. If I'd been careful here, I could have had the same binomial in both places without the added step of making sure that all the signs were the same between these two binomials here. Okay, so that's 3 more examples of factoring complex trinomials. Go ahead and ask some questions.